welcome back to the workshop. So in the last video, unfortunately, I managed to break the encoder. So whilst we wait for the new one to arrive, we may as well get on with the last job, really, last big job, which is to get the case or the cover on the end here, get it modified. So I've got to cut a little hole out there for the wiring cables to go through, and obviously one for the motor, and then we'll make a nice little enclosure that goes over that to protect it. Right, so I think let's get started. So I've already marked up the cover, so I've got the cutout there for the wiring harness, and then down here another cutout. This is the main one for the motor. I'm going to try and keep this if I can and just have a window, but you know, to keep some strength there, but I might end up, depending on where the motor ends up, might chop that out as well. And then there's a little return flange on here that might get a little bit close down here to the pulley, or it might mean you have to sort of come round when you fit it. I don't know, we'll have a look. We'll do that last. Right, so I think we'll start here, cue the grinder and cue the music. It's clear of the motor. It's going to go onto this stud at the bottom here. The lower part looks like it's going to go just catching where that wiring cable tray comes out there, so maybe take another 5-6 mil off there, and I think that will go on. Can I get it off? What's that caught on? There we go. Yeah, it just needs a little bit off there. Just taking a bit more out of that bottom corner. I think basically fits now. One thing I have noticed is obviously this, I haven't really taken account of the size of that thumb wheel. Now the idea is I won't be taking this on and off really. I don't need to change the speed. I've got the variable inverter for the variable speed, and then this will do all the different feed and cut rates, so could just replace that with the regular nut, or what I might do is turn down a much slimmer but longer one, knurled sort of cylinder. It's only maybe 12 mil or so, because I need to make the cover that goes through here. But anyway, that's a bit of detail we can do. Okay, so it'll be pretty straightforward really. I've just got two pieces here, 10mm thick, so they'll come out of the side like that, either side of the motor. And then I've just got a sheet down here, 2mm sheet, and then I'll just fold that, and then that will go over the top and down the back. The bottom will be open, but that's okay because that's near the ground. So you'll have the two side pieces quite thick, and then a top piece and side piece there, or front piece, made out of this sort of sheet to cover, and then it will be screwed in place a couple of places. This itself will be screwed to the through the cover, so it'll come through the cover into that to leave those pieces sticking out, and then there's a couple of extra fixing holes to screw this to. So, you know, pretty straightforward really. So I couldn't find any 10mm stock, so I'm going to have to order some and wait for that to come in. I thought I had a bit, but I've just checked through my boxes and I don't. But I do have the sheet here, 2mm sheet, so we'll get cutting that. I'll just use the grinder, get it set up with a nice straight edge, and then we'll cut that out, mark the holes on the surface plate, and then just drill those. There are any clearance holes, and then we can fold it and then hopefully by then this material will arrive and we can machine that and drill and tap the holes. Right, let's get started. So after I finished cutting the shape out of the grinder, it was over to the surface plate, then mark up the holes, centre punch them, and then here we are just piloting them out and then bring them out to full size 5mm. And then we're on to the next step here, which we need to fold it, and the fold line is 86mm from this edge. So I've just got my calipers set to 86, and we'll use that tail measurement there just to get it set up correctly in the bender, and then we'll put our 90° fold on. So as you can see, we've got the bench mounted folder set up here in the vise, and that should be yep, 86 there, 86, 86, yep. Now I'm just looking down here and I can see there's a little bit of free play before it hits, so I'll just adjust those sides. They occasionally move, you know, it's not a super expensive bender. Just get those set. I've got that set straight, got everything so that it's level and the gap is consistent. That gives us our best chance of bending a nice 90° fold on it. Right, so I'll set that and then we'll put the fold in. Okay, I've also just slipped a little bit of paper under there. One of the modifications I want to do to this is just build this edge out with another plate to make this a little bit wider, because you get quite a lot of stress, you can imagine there, whether that's bending that. It'd be better if this was a lot wider, maybe a bit of box section welded on or something, just so it pushes onto more of this material, or reinforced angle line, something like that. But anyway, for now, that will reduce the witness mark to sort of a reasonable level. Okay, so let's put the bend on. Right, let's see where we're at. 0 on there. So I think these come a little bit more. Okay, just a tiny bit more. Here's 0. Yep, okay, we'll go with that. Okay, let's see how we did. Okay, that looks good. So I'll take the film off right at the end just to try and keep the surface looking nice. Don't know what they are. Anyway. Okay, so that's those bits done. So this is kind of the cover that goes on top. And now we need to make the sides that go in there, which I think were 10mm plate. So they'll go on there, and then the whole thing, yeah, the end cover will be here. And that should protect the motor. Right, let's go make the side plates and then we can put it together. So I'm in the middle of just drilling and tapping these all out. I've drilled them clearance down to 15mm, and then I'm just tapping down to 10 using the little readout on the side of the quill here. So I've done 3, got 1 more to do here, 2 on this side, and then we can put the cover together. And then I've got to mark through from the other end those holes so they come through the cover and into the back piece there. So let's just tap this one. So in CAD I've just drawn up this paper template. So this is the reverse of the cover that's going to go on here. That'll just show me where the mounting holes are. And I just made it a little bit bigger just so we could have something to stick down. So I've got it lined up at the edges, and then that line there represents the lower underside of the top cover. So it will come to about here, so it won't leave any gaps. Right, so let's we'll just visually align these and make a hole. It's only going to be a clearance hole, but let's see how close we can get it. And now my favourite bit of all, peeling off the film. So you're probably wondering why I'm using these socket head cap screws rather than these button head ones. The answer is these are the only ones I've got left, M5, and they're really long. So I've got plenty of them, but I really don't fancy cutting 8 of those, 12 of those down. So I've got loads of these, so we'll use these for now. I've had these button head ones on order for quite a while, maybe at least a week now, but they're obviously stuck in the post somewhere. So when they arrive, I'll swap them out. I think I ordered 10mm long or something like that. But for now, just to make sure it all works, get all the holes aligned and everything, we'll go with these. Right, now we need to get this fitted into the main end case. Alright, let's see if it lines up. There we go. Trouble is, some of these short ones are ones I've cut a long time ago, and I think the start of the thread's got a slight burr on it. Last one. Well, it'll work. Just look a lot better, I think, once I put the button heads on instead of these. And then there's that knurled nut that I'll need to make that new one that's a lot smaller in diameter. Or I could just put a normal nut on there. It's not like I'm going to be taking this on and off very much. So I've got the variable speed motor, got the inverter drive, and then I'll have the variable feed as well. So could just put a wing nut on there or something like that. Anyway, the main point of this bit was to get that cover on and I'm pretty pleased with that. Okay, so need to have a bit of a think about if I'm just going to leave that, just polish it up, or whether to paint it. I'm certainly going to have to obviously tidy this up and paint that, so maybe when I'm painting that I'll do this at the same time. Anyway, functionally, looks like it's going to work. Went on okay. Obviously I'm not going to be taking this on and off very often, and as I suspected, yeah, it's a bit close really. I'll just rub on there. I'll make a smaller one, or yeah, a little tiny nut or some kind. Anyway, that looks okay. Pleased with that. It's going to do the job and protect the motor, and it's really out of the way. I don't use this area very much, especially now I don't need to take the cover off. Yeah, looks alright. Okay, so the encoder arrived about a week earlier than scheduled, so yeah, that was nice. So here it is. I've soldered it together. Quite a novel use, I think, for the hex collet block there. I think it was a 12mm collet. Made that so much easier just to hold it firmly in place while I soldered it, and then rotated it round. And then just a double, triple check. I opened the case up and did a continuity check just to make sure I definitely wired it up correctly. Then it was on to setting it up on the machine, routing the wires, putting the cable ties round, and making sure the belt was running pretty true and not too tight, but just about right. Okay, why is that not on? Ah, that might help. Well, at least I know that works. The display works and the DRO works. How have we got on RPM? No. Okay, I just used the multimeter just to check I was getting 5 volts out of there, which I was, so I plugged it back in, and now it's giving a reading, so I don't know what that was all about, but let me show you. I'll have to set the default to millimeters, and yeah, feed, that's okay. But now, I'm getting something, I suspect the calibration is wrong, that I've put in the code, but that's okay. We're getting a signal. So it looks like it's working. Right, I will try running it with the lathe, and we'll see if we still get interference. Remember I added that filter, so let's see if that's made any difference. So as you can see, that's clearly out. I think the minimum's at 150. Well, we could look into that. Not flickered yet, so that's encouraging. What was that noise? Alright. Oh, and I've just noticed it's actually running the motor. As you can see, it's slowly turning. I think, apart from the calibration or steps per, you know, all that kind of stuff, it seems to be going. So let's put the feed rate up and see what happens. All the feed, yeah, okay. So it should start to go faster. would say is that max. That's working. Right, I've just got the half nut engaged and let's see what happens. Okay, so the RPM's working, it's rotating, and that is rotating very slowly. Yeah, so it's going this way, so it's going backwards. Alright. Okay, so I need to sort the calibration out on that, number of pulses, all that kind of stuff on the encoder and for the motor, and I need to turn the direction around on the dip switches. Well, that's pretty easy. And then we need to get the cover back on because it's not super safe at the moment, but really pleased. Yes, finally working. That's a real milestone. Really pleased with that. Right, let's get all those little jobs sorted out and we'll get the cover back on. Okay, so as you can see, I've brought the unit in the house. I thought that was quicker than trying to flash this software or upload this software onto the workshop PC that doesn't have an internet connection. Because I remember last time it went back and forth a few times and I think it had to re-download some updates, some firmware, whatever, and it's not on the internet, so I'll be forever going backwards and forwards. So I thought it was quicker just to unplug the cables, take the box off the wall and get it set up down here. The only one thing I had to do is I forgot it wouldn't come on a few minutes ago, and I realised it's because the e-stop is disconnected, so I've just had to hotwire that. I mean, I'm not running it, so there's no risk. So I've got everything disconnected, I've got my power going in. This is just a converter, just to convert from male to female, because that's the cable I had. So that USB goes to the front of my PC tower down here, and it's just plugged into the front there, just so it can communicate. So as you can see, I've got James's video up there, just to remind me how to connect it to the board, and then how to flash the software across there. Because there's a couple of different ways. There's a different modes you've got on here, and a few different buttons you need to press just to get it to upload the code. I've basically gone through and done that, and I've configured it for my machine in terms of the lead screw pitch, the encoder count, the servo, pulses per rev, and the gear ratio, etc. It's all well documented in the code, so I'll just talk you through that now and just explain what I had to change to get it to work for my machine. Obviously, if you're building a project like this, you need to configure it to yourself, whatever you have. I'm running metric, so I've got a metric variable I needed to set in here as well. So let's take you through how I set this up. Okay, so we're in the configuration window now, so if you double click on configuration.h, you can see this bit of the software. And the first thing you'll notice when you come into here, certainly this version of it anyway, it's version 1.4, is you've got your lead screw pitch. Now I did some testing on this, and I determined it was a 2mm lead screw per revolution, so every time it goes around once you get 2mm of movement. So this is in hundredths of a millimeter, so you put 200 in there. The next one is the stepper servo. Now I've got this set up at 3:1, and if you read through the text here, it just tells you then put that in the micro steps, 3:1 ratio, and then in terms of your resolution, I've got that set currently on the servo to 1600, so I'll put the 1600 in there. As you'll notice as we go through this, I've commented out the original code, so if I've changed something, for whatever reason I want to change it back, or it screws it up, whatever, I can go back. So just put the 2 slash marks there, / marks, just to say that was the old code, and then my new one is next to it. I'm not using a separate lead screw for feed for my feeds versus thread cutting. It's basically the same lead screw, so I don't need to change that. My inverts, this was all correct for me. I didn't need to invert the step and direction. I'm using actually the same servo as James, so I left that as default, and enable the alarm, and the enable and the alarm are okay like that as well. So this is as it was, so I didn't change that. Then the other one, I'm using the encoder that James recommends. Now it's using counts per revolution, and as I went through in the previous video, that's quadrature, so every time it goes around you're actually seeing 4 times that, because you've got 2 pulse streams, A and B, and you've got the rising and the falling edge are both counted. So it's 4096, so I kept that the same, and I'm using the first encoder. I guess the board has the ability to run a second one. Using floating point. Now James went into this in great depth in his videos, so I left that alone. I think that was all I did on there. Yeah, these are just defaults, you don't need to change those. Okay, now in theory that's all you need to do to configure your device, so you got your steps per and your resolutions and so on. I was having a little look through this, and I think it was I'm doing this live now, was it the interface one, or was it control panel? I know, yeah, it was the interface, the CPP file for that. I was just playing around here and I noticed that this is the startup messages that you get, so you get ELS and then the version 1.4 in that bit of code there, and then the startup was Clough42, and just to mess around, you can see that in the original there, I've just commented that out as Clough42. I've just put router CNC, although I had to stop at CN. Now I don't know, I did look elsewhere in the code. It did suggest it would only take 8 characters. I don't know if you gave it 9, because I'd need another C on the end of that to make CNC, whether it would scroll round, but so I'd just play it safe just for now. I just left it at 8, which is the same amount that James sent across as well, because I don't really want to take this apart twice, you know. That's just going to slightly change the startup display, yeah, just messing about a bit. The rest I think I left as it is, and I flashed this onto the box, so I think we need to put it back together and see if it works. Okay, well, as you can see, I've got it all connected back up again, hooked onto the wall. It's actually quite awkward to get those screws in the back there, and the one at the top, so I think what I might do in the future if I do a cabinet like this is get those screws screwed onto a plate, so before I mount any of the electronics, and then have the plate kind of hanging outside the box, so basically the screws will be above and below the box on the outside, and there'll probably be sort of keyhole or slotted screws so you can just drop it on without taking the screw out the wall, especially if you need to take it on and off a couple of times. Anyway, we're there now. If I have to take it off again, I might make an adapter bracket, because getting the screwdriver in is a bit awkward. It's working now. I've taken the override off the emergency stop. Also noticed I had my fan wired in on the other side of the fuse, before the fuse basically, so I've swapped that round, so it's all a bit safer, and hopefully that'll work now. I've also put a little bit of tape on those 2 DuPont connectors, so I know if I ever take them off, then this one's obviously facing out and that one's down, so you can see them. Right, let's switch it on and see what the calibration's done. Did you see the display message? I've forgotten I'd done that. Yes, I changed that to say router CN, well, CN anyway. Right, notice that's jumping around a little bit, but hopefully that's okay. Right, let's see what happens if we turn it by hand and see if we get a lot more RPM, and see if the motor moves. Actually, I've just noticed one other thing. It was defaulting to inches, and now it's come up in millimeters, so the software defaults are now working. I tend to work in millimeters. It's come up in feed, I think that was the default, and it's come up in forward, that's the default as well. So if that's jumping around, or if that's getting a bit of interference, or yeah, well, let's see what happens. We are getting a reading, and you probably can't see it, but the motor is moving very slowly. And it's moving the correct way this time. Or maybe we'll switch it on and see what happens. Yeah, I think I pointed it out last time. It's probably not easy to see, but it says switch 5. It's got on and off for clockwise, counterclockwise, and the little dip switch down here, I've just changed the direction and it's going the other way now. So simple as that to reverse it. Okay, let's start the motor. That's still not right, is it? Makes me wonder if I damaged the microprocessor board, maybe. jumping around a little bit as well, so I wonder if it's not that stable on the signal. Well, it's turning the motor and it's turning it the right way, so there's something. It's turning that. It feels like it's juddering slightly. I reckon that's not getting a clean signal. Okay, so I've got a few things set up here. So I've got the power supply back there for getting independent 5 volts. We've got the oscilloscope here, and then this down here is a function generator. I bought this a few years ago off eBay and I've never used it, but I've just got it set up so it's giving a square pulse out. Unfortunately the maximum is about 3 volts, but as I've determined that is enough to run the system up here and artificially put a sort of pulse train in. So let me show you what I found. Okay, so first of all I found that the 5 volt power supply was bad. Obviously it's damaged that as well. So I've got my independent power supply running there at the moment, but let me just show you, because that's on as well, just being careful what that looks like. So that should be a nice steady line, DC line, but clearly something wrong there. Maybe damaged the rectifier circuit because it looks like it's giving positive and negative there. But yeah, okay, that's the first thing. So yeah, I could look to fix this, but I've just had a look online, £12, so I've ordered one. Should be here in a week or so's time. But in the meantime, I can run with this 5 volts that I've got here from the voltmeter or power supply. Okay, the second thing I want to check out is I've got my, this is a function generator. I've just got the scope set up for that. So if we just zoom in a little bit, and I think we've just got this set for, is this on the square wave? It's supposed to be a sine wave. Yeah, so you can see it's sine, it's clipped, but that's because it's about at the maximum amplitude. I've turned the volume up if you like, just to see what happens and see if we can get a pulse train in to at least run the servo. So instead of connecting here, we'll put it into the servo control cables and see if we get some output. Okay, so we've got the other end of this is coming from the output there, generating that pulse train, and up here, just being a bit careful because this end is live. I've disconnected the plug and a bit awkward. I need to touch on those first two there. Okay, so put the pulse train into there, which runs down to the servo driver and the servo. That was nice and smooth, no hesitation, no problem. Right. Oh, I should have mentioned earlier, even though I've tried running this, oh, let's just show you what that looks like. Hold on. Okay, so I've got a 5 volts in the power supply, going to the 5 volt, boards come on, all the lights are on, and then we're just checking that signal here. And yeah, one division's 5, so that's 5 volts. We can zoom in and it's pretty nice and stable, noise free. Unfortunately, it still doesn't work with that bypassed, so there's something else. So what do we know? Well, we know that's damaged, but if you bypass it, it still doesn't work. If you look at the servo system and put some pulses in there, that works really well. So the next thing to try is, as you can see, I've got the optical encoder plugged into the second output, because you can have 2 of these encoders, because it's possible either I damaged the encoder, but that's brand new, you know, I've just rewired that in and just check that works on the bench, so we know that's okay. So it's probably damaged the motherboard on the chip. I think it was U8 or U9, I can't quite remember which it goes into. I guess it's possible I've damaged the boost board, but the lights are all on, so hopefully that's okay. Right, so I've moved it across the second optical encoder. That once it was plugged in there, it's now there. Unfortunately, I need to take the board out back in the house and reflash it to tell it to use the second encoder, and hopefully that fixes it. If it doesn't, I'm going to have to buy a new microprocessor board, I think. Oh yeah, I also bought a new tool to get the unit off the wall, which is this. 300mm extension made by, I think, say people who make the screwdrivers, and WERA. Feels nice. Certainly expensive enough, £15 just for that from Screwfix, but hopefully that'll do the job. Right, here we go. Then I took it into the house again, connected it up to the computer, fired up Code Composer Studio, and then I had to make a change. So I commented out the line that says use encoder 1 and then added or included the encoder 2. Here we are flashing the software across to the board. Then you can see the little blue light flashing, say, yep, the code is going in. Then back out to the workshop. Okay, so obviously I've got the unit back on the wall. That really long 300mm extension made real short work of that. Turned like 20-minute job was really fiddly into sort of a 20-second job really, so should have bought that earlier. Anyway, it's magnetic as well, so it's holding the screw in place, so brilliant. Okay, so as you can see, I've got these lines in here that run the auxiliary 5-volt power supply in because that little unit there is broken. Okay, and then you can see I've got the encoder onto the second input there, so it was in the middle on there. That's EQ1 or something like that, and then that's EQ2. Now, having a little look through the manual, I was thinking this is going to get quite deep and there's going to be a lot of coding. There are all sorts of parameters, GPIOs to set up, GMUX to set up, which I guess means multiplex or something like that. A whole load of coding was going to be required to say move from 1 to 2. I had looked through James's program. I had seen earlier that he'd got declaring a variable whether you're going to use input 1 or 2, and you just define one or the other. But I didn't know if he'd done any more than that. Luckily, he's thought ahead. Brilliant. So if you look somewhere else in the program, it's got all those defined, all the inputs and outputs, all the terminals, and all it does is said, if variable 1 has been declared, then use this set of setup parameters for all those, and if variable 2 has been declared, which is what I've just done, it uses the second set of parameters. So it's all done for you. You just change one line of code and you can use the second input. Anyway, we don't care about that. Does it work? So we've got our readout there, that's okay, and if I manually turn this, okay, it's jumping around a bit, but that might be because I'm moving it. Right, let's try it under power. Got to be a bit careful because the belt's exposed and my power supply's down there and I don't want it to become part of the machinery. So, here we go. That's looking good. It's jumping around. Oh, hang on, a little blip. Oh, is it? Oh, it's gone. That looks alright for a minute and then it's jumped down. I wonder if I'm getting interference. So I've just put the digital readout, which is the power supply that goes all the way to that box in this extension reel, and then this is going all the way over to the other side of the workshop, so I've got 25 meters in there, plus it's another part of the circuit, so hopefully that'll give it a bit of isolation. Right, let's try this again. Yeah, it's too low, something going on. The good news is, if there is some, with that RPM, whatever it's doing, it is actually driving the motor, so most of it works. It's just getting a reliable speed signal that's the problem, I think. Okay, I think we'll call it there. It's getting quite late. I'm getting pretty tired. So let's reflect on what we have managed to do. So we definitely know the servo works. If we put the pulse train in, then that moves nice and smoothly. The display is working in that it's lighting up and it's showing the numbers and you can operate the controls, but there's something wrong with the RPM feed. The encoder's brand new, so can't be that, can it? And we've gone across onto the second channel, so hopefully the microprocessor's okay as well. So I've got some thoughts about I still think there's probably some interference somewhere. I just need to get the scope out again and just go through the system and see if I can find out where it's coming from. grounding problem maybe, you know, and have a look and see what's going on. But for now, we'll call it there, and then we'll pick it up in the next video, and hopefully we'll solve that. We also know the 5-volt supply is not working, so obviously got that in standby, so I can use that until the replacement one arrives. I think that's it. So yeah, we've achieved quite a lot. Got the end cover sorted out as well, so I'm pleased with that. I need to paint that, I think, or work out what I'm going to do to make it look a bit nicer. And I think that's it. Okay, so if you're enjoying this series, you want to see more of me go around in circles trying to work out what's going on with this system and trying to diagnose it and pulling my hair out, then feel free to subscribe. If you've got any comments on that along those lines, then feel free to drop those down below. As always, hit the bell icon if you want notification and all that kind of stuff. And all that remains to be said is thank you for watching, and see you next time.